Welcome back. We're going to do an example using the p-value using the t-test. So we have an example here of water consumption. We have the Old Farmer's Almanac states that the average consumption of water per person per day is 123 gallons. Now that's your mu, okay? That's your status quo. To test this hypothesis that this figure may no longer be true, we have a researcher that randomly selects 16 people and finds that they use on average only 119 gallons per day. Now, there is a little bit of data here. So this is my X bar. The 119 is my X bar. And also, I do not have the standard deviation of the population. So I would have to use the sample standard deviation. Whenever you do the sample standard deviation, you have to use the t-test. Now, this has to be at a significance level of 0.05. And they're asking us, is there enough evidence to say that the Old Farmer's Almanac figure might not be correct anymore? All right, so let's work through this example. Let's see what we have there. So let's begin with, we can't really test conditions. They did tell us that he took a random sample, but they didn't tell us whether it comes from a normal distribution, and we do not see any kind of a distribution that we would be able to gauge by looking at the distribution that it's normal. So we have to take it on good faith. Well, let's see what we know first of all. We know that the researcher that did this research knows that the X bar is 119 and that the S of X is 5.3. I also know that we took 16 people, and that's a nice number because when I want to calculate my sampling distribution for the mean of a sample deviation, then I'm simply going to take the S of X and divide it by the square root of n. And this is why I'm saying it's nice, because the square root of 16 is just 4. So 5.3 divided by 4, I have 1.325. Okay, now let's state our null, which says that there is no difference, that right now we are actually using the same amount of water as we did forever and always. So the null over here is going to say that the mean of the population is the same. And the same means that it used to be 123 gallons per person per day, and it is still that. The alternative, though, sort of doesn't have less or more. It just says that it's not. This number is no longer true. So when we're going to be looking at this kind of a test, we are actually looking at, what do you think, two-tail or one-tail test? If you said two-tail, you are correct. We are going to be looking here at something that is going to have two tails. So we used to be at 123, and now we think that the actual deviation is further away. So it could be either way, but it's going to be two sides. So for that, and my alpha is 0.05 over here. So for that, I know that each region over here is going to have 2.5%, but it doesn't matter. So we're going to sort of use the p-value method. So the p-value method is going to say, what is the value under the curve? If this value is less than, if these two values together are less than 5%, then go ahead and reject. If it's more, then this is just a random variation due to variability. Okay, and the last thing before I'm going to go and pull out my table, if I have asked 16 people, what is my degrees of freedom? If you said 15, you are correct because it's n minus 1. Okay, so it's a two-tailed test, okay, with significance level of 5% at 15 degrees. So looking for the p-value, and let me zoom out of this a little bit. Okay, so you can see this. So it's a two-tailed test. I'm looking for 5%. Here's my 5%, and I need 15 people. So this would be my significant value. But figuring out p-value, I would have to calculate my my test statistic. So let's go ahead and calculate our test statistic. And you remember that is going to be whatever the observed value, which is 119, minus your value that you expect to see, which is 123, and then divided by the standard deviation of the sampling distribution. And in this case, we're using the sample standard deviation. So I'm going to divide that by 1.325. Right? So essentially, I take this and I throw it in there already. I just calculated it ahead of time. Okay, so what is that going to be? That is going to be negative 3.09. Okay, so you already know that this is fairly far away from the middle. That stuff doesn't happen by chance. Okay, so what is the probability, what is the p-value to be that far away from the mean? Okay, we're below the mean. We're somewhere in here. What is the probability for that to happen? Well, let's look at our table. The probability of that happening at 15 degrees freedom, okay? Do I have a 3 here? No, that's not 3, so not 20%. Do I have a 3 here? No. So actually, the 3 is off the chart. So your probability of getting a value so extreme is less than 1%. Okay, so your p-value, the probability of having t less than negative 3.09 is actually less than 1%. Now, remember that this is a two-tailed test. So you would have to take that less than 1% and double it. But even if you double less than 1%, you get less than 2%. And less than 2% is going to be less than 5%. Since your p-value is less than your alpha, okay, so this is roughly 2%. Okay, we're a little bit exaggerating. And 2% is indeed less than 0.05, which is 5%. Okay, I am going to reject my null. Okay. Hurrah, we have rejected the null. That means that we have sufficient evidence to say that the mean water consumption nowadays is actually different. Now, we're not saying that it is different, but we have sufficient evidence to say that it is different. Okay, we could have a sample that is not representative. It could be variable, but this is what it means.